Hirschman, and this is your 8.4 lesson summary. Unit 8.4 will be on calculating and interpreting the standard deviation. So in Unit 8.3, we first introduced you to the idea of an outlier, a data set that doesn't quite fit in with the other data. It's either too far above or too far below the majority of your data. Standard deviation is going to be yet another measure of how spread out the data is. We did an interquartile range last time, and that was how far the data is spread out from the median. The standard deviation is a measure for how spread out the data is from the mean. And it'll be using averages a little bit more, just like a mean does. Now, with this same study, there's also different types of distribution you can look at. And for what we're doing here in Math 1, we're really just going to look at what a normal distribution is. When you get farther into statistics, you can see other types of distribution that exists. A normal distribution is a collection of many data points that form a bell-shaped curve. And I'll show a little bit more about that later. Now, the formula for standard deviation is very intimidating, to say the least. It's going to look very complex. So I'm going to show it to you in that notation because it's important that you see that and that you start to learn and understand what these symbols mean in math and that you can read the language of math. But I'll also write it in a little more easy to understand terminology for you as well. So the symbol for standard deviation is the symbol here. It's like a cursive O. And the actual equation for it is the square root of, remember we just learned before that sigma means the sum. So it's the sum of every single data value you have minus the mean squared. So if my data values were 1, 2, 3, 4, 5, it'd be 1 minus the mean squared, 2 minus the mean squared, 3 minus the mean squared, 4 minus the mean squared, 5 minus the mean squared. So I'm going to have to do a bit of work there. I'm going to take all of those, add them all together, divide by the number of numbers n, and then take the square root of that final answer. So in other words, it's the sum of each data value minus the mean, in parentheses, squared. I'm going to add all those up, divide by the number of numbers, and take the square root. It'll be a little easier when you actually get to work through the process with me. Now, where are outliers in regards to a standard deviation? Well, kind of like we did the interquartile range, you had to be a certain amount away, an upper fence and a lower fence. We kind of have the same idea here with standard deviation. Outliers occur when you have data values that are more than 2 standard deviations above the mean or less than 2 standard deviations below the mean. Okay, and I'll show you how to do that as well. Okay, so let's get started. Let's try it. So here I have a list of games, 1 through 11, and joules captured. So they're playing something like Bejeweled and keeping track of their scores here. Okay, we're going to find the mean, standard deviation, and any outliers of this data. So let's start by finding the mean. We've done that previously. The mean is found by simply adding up all the numbers and dividing by the number of numbers that you have. So just make sure I didn't miss any. I should have, looks like 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And I'm definitely going to want to speed this up by using a calculator to add these numbers. When there's a lot of data sets, I can also use the functions I learned on the calculator to do a mean using 1var stats. But I also need to be able to do this by hand. I won't always have a calculator with me. Never know what will happen in the future. You might lose all the technology here, in which case we still want to be able to find this with our own brain and our own hands here. So adds up to 1,067. I'm going to divide that by 11, and I get a mean of 97. Okay, so now I know where the average of this data is. On average, he captured 97 joules. Okay, but are there outliers in here? Is there a number that kind of stands out? Well, the standard deviation will help me find exactly what that is. So to do that, it's going to take a bit of work. I need to first find each data value minus the mean squared. So I'm going to actually use the table here to help me. And I'm going to subtract each value from the mean and write it down. and then I'm going to take each of those answers from the table and go ahead and square them and write that answer down. Okay, and I won't show the work for every single one because it's a little bit tedious on my part to do, but I'll do it for the first few, and then you at home can do it on your own, and I'll just give you answers to check. Okay, but our first value was 105, and I'm going to subtract from it our mean of 97. So 105, let me write that a little smaller, this doesn't quite fit. 105 minus 97 equals 8. Okay, and then I'm going to have to square that. So 8 squared is 64. Okay, our next term was 101. 101 minus 97 equals 4. And then I would do 4 squared and get 16. And so now I'm going to continue to do that for each one. 102 minus 97 is 5. 99 minus 97 is 2. 110 is 13. Here now for the first time I get a negative number, negative 7. 3, 3, 1, 23. And then 32 minus 97 is negative 65. And now I just continue squaring. Some of these I'll be able to do in my head. 5 squared, 25. 2 squared, 4. 3 squared, 169. Negative 7 squared is technically here, negative 7 in parentheses squared. And so when I square that there, it's going to turn positive, and I'll get positive 49. So you should always be adding positive numbers when you're calculating standard deviation, because even a negative number will turn positive when you square it. 9, 9, 1. 23 squared is a little too big for me to do in my head. 5, 29. And then negative 65 squared is 4,225. So I personally find it easier to do a table for this. I'll take each value, subtract our mean of 97 every time, getting all those differences down, then squaring each of those differences. Okay? So I've done this first portion of the formula. I have each data value minus the mean squared. I now need to find the sum of those. So I can actually just take this table here and add them all up. Okay? I'll do that now, and I'm going to write that sum right here in this last little bottom box. So we have 64 plus 16 plus 25 plus 4 plus 169 plus 49 plus 9 plus 9 plus 1 plus 5, 29 plus 42, 25. So I'm getting 5,100. You guys check me, make sure I'm right. I don't think I am. Might have missed a number, let's see. 4225. 23. No, it looks good. I think I'm good. Yep, looks good. 5,100 is my total. And now my standard deviation at this point is found by taking the square root of the sum of each of the data value minus the mean squared, which we found to be 5,100, divided by the number of numbers 11. So I'm going to do the 5,100 divided by 11 first. Take the square root of that answer, and just so you can see, the square root, it'd be the square root of 463.63 repeating. And to keep it accurate, I'm going to try to use the answer function on my calculator. So I'll actually do the second square root of my answer to get this as accurate as possible. Otherwise, it might round a little too soon and make it off. So square root of my answer. And so just to show you how I type that. So I found the 5,100 divided by 11 and then square root of that. So my standard deviation is looking to be around 21.53. And that is the number I will use to try to find an outlier now. So where do the outliers occur? Well, it's the mean plus 2 standard deviations anything above that, or the mean minus 2 standard deviations. So I just have to work that out now. My mean was 97, plus 2 times my standard deviation of 21.53. Get that, and that'll be kind of like an upper fence, like we had before. And 97 minus 2 times the standard deviation will give me roughly my lower fence. So let's see what that works out to. So my lower fence is 53.94. My upper fence oops, sorry, I think I wrote that in the wrong spot. I'll fix that in a minute. Yeah. So 53.94 was my lower fence. Obviously, because that is less than the mean, wouldn't make sense to be my upper fence. My upper fence is 140.06. And so, just like I did before, anything above that is an outlier, anything below that is an outlier. So now at this point, I can just go back and scan my data, looking for numbers above 140. No problems there. Numbers below 53.94. Here it is. So that last score, that last game of his, he only had 32 joules captured. So 32 is an outlier of the data. So I can use the outlier or the standard deviation to identify outliers as well. One other thing I want you to be aware of, though, in addition to how to find the standard deviation, is how standard deviations occur, or how they, what they mean about the data. If your standard deviation is a larger number, then your data is more spread out. That means you have a lot more data pulled away from your mean. If that standard deviation is a really small number, the data is a lot to whatever that mean is. So when you see big numbers for your standard deviation in comparison to what your mean is, it means your data is a lot more spread out. So if I gave you 2 sets of data, and let's say one had a mean of 10 and a standard deviation of 1.5, and the other one had a mean of 30 and a standard deviation of 20, this data is not all that spread out, because the outliers wouldn't occur until 2 standard deviations away. So my outliers would be numbers above, 13, and numbers below 7. So that means the majority of my data is right there in between, close to 10. Doesn't go much higher than 13 or 7. When you look at something like this, though, 2 standard deviations from here would be 40. So your outliers don't occur until somewhere near 70. So there's a lot more data that is occurring in the higher numbers away from 30. So when I give you 2 standard deviations, the data that has the larger standard deviation is typically more spread out. But again, you do have to kind of roughly compare that to the mean to get a bit of a scale with it. Okay? And although it's not too much of a focus yet, one thing you'll look at in later statistics courses is what we call the normal distribution bell curve. And that idea is that the mean, if you plot the mean here, right in the middle, and then try to put where standard deviations occur, so let's say that's 1 standard deviation above, 1 standard deviation below, this is 2 standard deviations above, and 2 standard deviations below. And plot your data in a normal distribution curve, it'll look somewhat like this. And so the majority of your data, and they give you exact percents here of what it could be, something like 67, 68% occur in this zone. So the majority of your data should be within 1 standard deviation of the mean. And then something like 95% goes within the 2 standard deviations, and 99% within the 3. We're not going to make that a big focus yet. But that means frequency-wise, you should see things like this. Your data should kind of roughly follow this trend if it's a normal distribution, with the majority of the points occurring right here near the mean and within 1 standard deviation, with a lot less occurring out away from it. Okay, and when you get into AP Stat, down the road here in a few years, you'll get to analyze different types of distribution and what they look like and how they occur. All right, good luck. Thank you.